Good day to everyone. Welcome to our video. Today we're going to talk about binary tree, types of binary tree, some formula finding the level and number of nodes, binary tree traversal, and linked list implementation. Let's start with binary tree. A binary tree is made up of at most two nodes, often called the left and right nodes, and is a data element. The topmost node of the tree is called the root node, while the left and the right pointers are directed to a smaller subtrees on either side. Here's a question. Is this a binary tree? Well, the answer is no. This is not a binary tree. As mentioned before, binary tree can only have two nodes or subtrees at most, and this has three subtrees in their parent. This can be acceptable by the program. It is called trinary tree, but in this video, we will focus more on binary trees. Now you know what a binary tree algorithm looks like. Let's now proceed to the types of a binary tree. Full binary tree, complete binary tree, and perfect binary tree. Full binary tree. A binary tree is full if every node has 0 or 2 children. For better understanding, let's take a look at this. This is a full binary tree. This ends with 0 or null and 2 children. This means that every node's child is filled with its full capacity. Another type of binary tree is the complete binary tree. A binary tree is complete binary tree if all levels are completely filled except possibly the last level, and the last level has all keys as left as possible. This is an example of a complete binary tree. Notice that the last level of keys are filled with or without the right subnodes. Left child or left nodes must be filled. You cannot do inserting the node in the right at last level. This is also considered complete binary tree. Here's a tip. When doing a binary tree, the program reads the left side of the binary tree first to be followed by the next subnode or parent node. Now, how can we count the maximum nodes for each level? The answer is simply 2 to power of I, where I is equal to level. Here is a sample binary tree. To count the nodes using the formula, consider this is a number of level of a tree. Starting from the root, we have level 0, then level 1, level 2, and level 3. To use the formula, make I is equal to level. We have 1 node in level 0, 2 nodes in level 1, 4 nodes in level 2, and 8 nodes in level 3. Alright, now let's move on and go back to the types of binary tree. And the last type will be the perfect binary tree. A binary tree is perfect binary tree in which all internal nodes have 2 children and all leaves are at the same level. As you can see, all nodes are completely filled and in with the same level. We have the formula 2 to the power of I, where we can find the maximum nodes in each level. To count all nodes in perfect binary tree, we just need to find the summation of all nodes. We have 4 levels here. Level 0 is counted and we have 15 nodes in this tree. The easiest way of solving this is this formula. 2 raised to n plus 1 minus 1, where n is the maximum level of tree. Now, we're done talking about the types of binary tree. Now I have a question. What are the binary tree traversal? In this topic, we have pre-order traversal, in-order traversal, and post-order traversal. Let's have the pre-order traversal. In pre-order traversal, the root is visited first, followed by the left subtree and the right subtree. Hence, it is also known as NLR, or Node Left-Right Algorithm as well. In pre-order, first to be executed is the root, up to the last left subtree. When it hits the null node, then it will execute the right subtree up to the root, but will not repeatedly execute the root. Then will now execute up to the last right subtree. In this tree, we can have the output of F, A, E, I, D, H, B, C, and G. As you can see the code, in the method pre-order_print, we have the condition if start. The first process to make is the traversal equals traversal added by a string value, which is the root. Then the traversal equals self.preorder_print start.left and transversal, which is the left node. And for the right node, traversal equals self.preorder_print start.right and transversal. You can see the full code later for better understanding. Now let's go to in-order traversal, or the uses of in-order in case of binary search trees, or BST. To get nodes of BST in non-increasing order, a variation of in-order traversal, where in-order traversals reversed, can be used. In in-order traversal algorithm, the left node is the first to be executed, then the parent of it, followed by the right node. Here in our tree, the output is I, E, D, A, H, F, B, C, and G. When coding, we have to consider the algorithm of an in-order traversal, left parent or root right. In method in-order_print condition, it first processes the traversal self.in-order_print start.left traversal, which is the left node, then the string value, the root, and the self.in-order_print start.right traversal is the right node. The last method is the post-order traversal. In this traversal method, the root node is visited last, hence the name. First, we traverse the left subtree, then the right subtree, and finally the root node. Here in our tree, the last subtree in the left executed first, and then its close related node in the right before the parent or the root of the subtree, same as the right level of tree. Then, lastly, the root. We have the output here, I, D, E, H, A, G, C, B, and F. In the code, method of post-order_print condition, the traversal is self.poster_print start.left and traversal. Then the self.post_ordered_print start that right traversal. And lastly, the root string value with a comma for the division of elements. Now, using the binary tree linked list implementation, here is the full code and output of the discussion. You may pause the video and take a while to review, analyze the code given in the screen. And here's a question for you. What new knowledge about binary trees is the most interesting for you? Do you suppose you'll make use of these trees in your profession? For your answers, please comment down below. This will be the end of our discussion, and I think that you will rock it. If you find this helpful, put a thumbs up in this video by hitting the like button, and don't forget to subscribe. You can also share your thoughts, input, and opinions in the comments section. Thanks for watching!